Hey guys, and what is today? Thursday? Happy Thursday. Today you don't have any work to do besides copying these notes down. And the reason that I'm saying that is because I have 3 pages of notes to go over with you. I've spread everything out onto its own page. But there are a lot of notes today that I want to kind of briefly go over. So I don't want to give you any other work to do besides getting all of these notes down and making sure that you understand them. And then we will move on from there. So the last thing that we talked about was point slope form, which is just another way, another form that you can use to get your equation into slope intercept form. So you can either take a point and a slope and plug it in here and get your slope intercept form so you know how to graph it, or you can just plug in your point and your slope into the slope intercept form itself and just solve for b. And then you've got the two things that you need. So those two were 2 ways that we talked about getting it into slope intercept form, but I'm going to show you 3 other ways to get your equation into slope intercept form. And they kind of all build on the stuff that we've talked about, and you'll start to see a pattern. Once you've got 1 or 2 things, you've got enough to do the rest of the problem. So I gave you guys 2 points when we first started talking about linear equation, and I just told you guys to find the slope. So I gave you 2 points, and you were able to tell me what the slope was using your slope formula, y2 minus y1 over x2 minus x1, which is what we see right here. But what I want you to do is take that a step further. So once you've found the slope from those 2 points, you can then use slope and a point to find your whole equation and solve for b and get your slope intercept form. So today's notes is titled Writing Equation from 2 Points. Given 2 points, use your formula y2 minus y1 over x2 minus x1 to find your slope, and then plug in one set of ordered pairs. And you can either plug it into y equals mx plus b, plug in your slope where m is, plug in your x and your y there, and solve for b to get your final slope intercept form equation, or you can plug it into point slope form and get y by itself and distribute and move this over. Either way, you'll end up in slope intercept form. And I've shown you both ways on this page. So let's move on to the first example. If this is your point 3, 6, and 4, 2, I've labeled them x1, y1. This is x and y of the first pair. x2, y2. This is x and y of the second pair. We used our formula like I just showed you a second ago, and we got -4 over 1. Well, we know that anything over 1, you don't have to write that. You can make any whole number a fraction by putting it over 1, so we're not going to leave that there. Our final answer is just going to be -4. Okay, so now that we have the slope, we can choose one of these points and plug it in for x and y. So I used slope intercept form, y equals mx plus b, and I plugged in my x and my y. So I used 4 and 2, so 4 is the x, 2 is the y, and I plugged in my slope that I just solved for, -4. I distribute that and got -8 and moved it over so that I could figure out what b was by itself. Now that I have m and b, that's all I need to get it in slope intercept form, and I have my final answer. Now again, you can do it a different way, and these 2 examples here, I used point slope form instead. You'll still end up getting your final answer in slope intercept form, but let me show you. From these 2 points, 2, 4, and 3, 8, I use my formula y2 minus y1 over x2 minus x1. So we have 8 minus 4 over 3 minus 2. We simplify it and we get 4. Now that I have slope, I chose a point. Just choose this one. You can choose this one if you want. It doesn't matter, but you're going to choose a point and a slope and plug it into point slope. So it's y minus y1. So here's the y value equals m, which I pulled from right here, x minus x1. So this is my x, 3. Now I know this is labeled x1, y1, but if this is the one that I'm choosing, this is the x and the y that goes into this equation. If I had used this one, I would have plugged in 2 and 4. So I'm going to distribute this 4 to both numbers, or both terms, I'm sorry. 4 times x is 4x. 4 times -3 is -12. And then we rewrite the equation. And I've got one thing over here with the y that needs to go away. So I need it to go over here. So I add it to both sides and move it over here. And I get my final equation. Y equals 4x minus 4. This is in slope intercept form. I'm able to graph with this because I know where to start and how to move. Again, like I've talked about many times, in slope-intercept form, you're able to see the slope and the intercept, or where the y-axis is crossed, or where you start. It's also called the b value. This is all in previous notes. Same thing here, I did the same process. Y2 minus y1 over x2 minus x1. I got my slope. I simplified it and got my slope. And then again, I used point slope form. So I used this point and this slope and plugged it in. So y minus y1, right here is 2, equals slope times x minus x1. And I use this x. So when I distribute that, I get negative 2x and positive 14. I bring everything else down, and then I move that 2 over. So my final answer is y equals negative 2x plus 16. So if you don't prefer point slope and you prefer to use slope intercept, here's my last example of that. We used these 2 points and we used our slope formula to find what our slope would be. It was 4 over 8, which reduced down to 1/2. Again, at any point during these notes, if you need to pause and just look at what I'm talking about before I move on, please pause the video. Make sure it's clicking with you and it makes sense, and then you can move on. So now that I did the formula for these numbers and I got my slope, I'm going to choose a point and the slope and plug it into my equation, y equals mx plus b. So if my y is 5, my m is 1/2, my x is 5 plus b. B is the only thing I don't know. So when I multiply 1/2 times 5, I get 2.5, and you can use a calculator for that, but you're basically taking half of 5, and it's 2.5. Bring everything else down, and then I need to move this away so that I can figure out what b is completely by itself. So I subtract 2.5 from both sides, and I get b is 2.5. So now that I know b and m, I just plug them in. And so this is how you would write an equation in slope-intercept form from 2 points. You use those 2 points to first find your slope, and then you just use slope point. Remember, we had notes on if you're given a point and a slope, how can you write your equation? So even if you're not given a point and a slope, if you're given 2 points, you can find your slope, and then you are working with a point and slope. So it's back to what we already talked about again. The next page, again, if you need to pause, feel free. I'm trying to roll through these notes in my explanation quickly, with the assumption that you'll pause when you need it so that this video is not terribly long. So we're going to talk about writing equations from tables. Okay, so up here I put, a table is simply an organization of points. Okay, so instead of writing them with parentheses all around them, we just stuck them all in a table. It's just organizing your points. So this is an x value and this is a y value. It's the same thing, it just looks different. So if this new method that I'm about to teach is confusing, just use 2 points, find your slope, and plug it in like we previously learned on the past page. If what is about to happen will confuse you, just pick 2 points, find your slope, plug the slope in, and choose a point and plug the point in, and you can get your equation that way. But there's also a way to get it from the table. So the steps are right here. First, I want you to label your X column run and your Y column rise, just so that we can look at this and say, okay, all of these X values are running on the X axis. All of these Y values are rising on the Y axis, so that we can remember that these are X's and these are Y's. These are run, these are rise. So what we're going to do is we're going to find the difference in our X values and the difference in our Y values. So from -3 to 0, what's the difference? Well, to get me from -3 to 0, I have to add 3. And then from 0 to 3, I have to add 3. And then from 3 to 6, I have to add 3. And then from 6 to 9, I have to add 3. And what you'll notice, we'll do tables in many other functions. But if the difference is the same number every time, it's going to be linear. Because we know that from one point to the next point, to the next point, to the next point, they all move the same way. You have one slope, one type of movement. So from one point to the next point, you move up 2 over 2. Well, again, you're going to move up 2 over 2. And then again, you're going to move up 2 over 2. And that's what makes a straight line, is because it's moving the same every time. So these should never be different numbers when we're talking about linear functions. If from here to here it moves by 3, and then from here to here it moves by 20, that is not a linear function. Okay, you're not going to be able to get a straight line when you're moving so differently. So these should all be the same. Same over here. From -3 to -1, we added 2. From -1 to 1, we added 2. From 1 to 3, we added 2, and so on and so forth. So what you're noticing is once you've found the difference, you're going to put that in a fraction form. You're going to put rise over run. So that's why we labeled it rise and run, so that when we're putting them in fraction form, we don't get it wrong. We read coordinate points x, y, but when we do slope, it's rise over run. So sometimes we get that backwards. So the slope for these points, when you graph them, they're all moving the same way. The slope is 2 over 3. Rise over run. All of these points go up 2 over 3, up 2 over 3, up 2 over 3, all of them. So that's the slope for this function. Now, if I then said, okay, I need you to write the whole equation for this function, all you have right now is the slope, but you can use any one of these points and use slope point and put it in slope point form and get it to your slope intercept form. Or, this is a really cool trick to remember. Anytime you see x equaling 0 somewhere, that is your y-intercept right there. Because imagine on the graph, if you are at 0 on the x-axis, then you are right on top of the y-axis. And I'll show you that in just a second on a graph. But anytime 0 is on the x column, whatever number is beside that, that is your y-intercept. So I put over here, your y-intercept is when x equals 0. So if you ever see x equaling 0, that number right beside it is going to be your y-intercept. So I don't even have to do any more math. Now that I found my slope, I can just look and say, oh, there's the y-intercept. Just write them together, just like that. So I'm going to show you 2 more examples that I did. So in this table here, I labeled it run and rise. X is run, Y's rise. And I just started to count the difference between each number. From -2 to -1, I go up 1. From -1 to 0, I go up 1. And from 0 to 1, I go up 1. So all these are moving by 1. And then on this side, from 2 to 5, I go up 3. From 5 to 8, I go up 3. From 8 to 11, I go up 3. So if I know my slope is rise over run, the rise side is 3. The run side is 1. So it's 3 over 1, which just reduces to 3. Now my y-intercept, I don't need to plug anything in because it's in the table. It's right here. Anywhere you see x is 0, that's your y-intercept, or my b value. It's just 8. No math is needed. Super easy. So once I find the difference in these numbers and I know my slope, always look and see if there's a 0 in that x value. If there is, that's your y-intercept. So I circled it for you. So when you write your final slope-intercept form equation, you'll have y equals 3x plus 8. 3 being the slope, 8 being the y-intercept that we just saw from the table. This one, however, you will notice there's no 0 in this table. So we can't just look at it and say, oh, the y-intercept is blank. So we found the slope by looking at the differences in our x values and our y values, and we got a slope of 2. And you can pause it if you want to look and check on that. Now, since the y-intercept is not in the table, we need to plug in slope and point. So you can either use point slope form right here, and I did that example, or you can plug it into slope intercept form and solve for b and make your equation. So if you plug it into point slope form, I circled the point that I used. I used -2, 4. So I plugged in 4 for my y right here. Y minus y1 equals m, or my slope, which is 2. X minus x1. So I have x minus -2, but 2 negatives make a positive right there, right? Don't forget that. That's important. I distribute and get 2x plus 4, and then I move this 4 over, and I get my final answer, 2x plus 8. And then in this one, again, I used 4 and -2, so 4 is my y value. Y equals m, which is 2, x, which is -2, plus b. I multiply those two and get -4. And then I add it to bring it over here, and I get b equals 8. So if b is 8 and my slope is 2, I put those together into my equation. So you'll end up getting the same answer. It doesn't matter which one you want to plug them in. Once you find the slope, choose a point. Also, you'll notice, though, if I kept going with this equation, if it's +1 every time, if I added one more, I would be at 0. And if I added 2 more, I would be at 2. So you can actually just keep going if you want to with your tables. I'm sorry, not 2. I added 2 from 0. 2 from 6 is 8. Whoops, I was like, this math isn't working. Okay, so if I add 1 here, I get to 0, and if I add 2 more from the 6 right here, I get to 8. And this is my y-intercept. So I can even double check it that way and find my y-intercept. The two things you need to get in this form are slope and intercept. Okay, I know this video is long. I'm going to try and keep it under 20 minutes, but one last page, and this is the easiest page. Writing equations from graphs. Okay, so really all you have to do is look at this. It's super easy. From a graph, you just look and you can see where it crosses and you can see how it moves. So in order to write an equation from a graph, the only thing you need is the slope and the y-intercept, or that b value. Okay, so the y-intercept is where the line crosses the y-axis. That's this line. This is my y-axis. The dead center going up and down that has all the numbers on it. That's the y-axis. So if I needed to know the equation of this line, the first thing I do is we figure out where to start. So we're going to start on the y-intercept, the b value. So if b is at -1, I'll write that down. Y-intercept is -1. Okay. Now how do I move to get to this next dot? I go to the right 3 and up 2. So I'm going over 3, up 2. Or you can go, that should be, or you can go left 3, down 2. But you see how it says +2, +3. What I did was I started from this point and I went up 2 over 3. If I had started from this point, I would go -3, -2. But we know 2 negatives still make a positive, so it's fine. It doesn't matter. But we know that we're moving either right or left 3 and up or down 2, right? So my slope is over 3, up 2. And if slope is rise over run, how much are we rising in both examples? We're going up 2 and we're going over 3. It's either -3, -2, which becomes positive, or +3, +2. So either way, our answer is going to be positive. So we're able to find our slope and our y-intercept literally just by looking and moving and counting. So I give you 2 more examples for this. I'm going to cover up the equation so you can't see them. So from this line, there are 2 dots. Let me zoom in some. There. There's a dot here and a dot here. So I'm going to start here because that's my y-intercept. It's where it crosses that y-axis, and it crosses at 4. 1, 2, 3, 4. So I wrote that down right here. My y-intercept is 4. So if that b value is 4, that's where we're going to begin. We got to move down to this dot. So I'm going to go over to the right 1 and down 5. 1, 2, 3, 4, 5. So from here to here, I went right 1, down 5. So if it's rise over run, rise is how much you're going up or down. So from this, like this movement, if we look, it's a -5. We went down 5. Run is this way. What did we write there? We wrote +1. We went to the right 1. So it's -5 over 1. That's all you need. Now you can write your equation. Y equals -5x plus 4. This is my slope. This is my y-intercept. Those two things. Very, very easy. Same thing here. So I have 2 dots. I'm going to start on the y-intercept. That's where we begin, that b value. So it crosses the y-axis at -2. So I write that right here. Y-intercept, -2. So from -2, I need you to move to this other dot. How are you going to get there? Well, we know slope is rise over run. So let's rise. 1, 2, 3, 4. Now let's run. 1, 2. So we rise 4, run 2, and it's positive, positive. And 4 over 2 just reduces down to 2. So my slope is 2. So the equation is 2x minus 2. So those are really easy. You literally just look at where the line crosses the y-axis first and write that down. That's your y-intercept. From the y-intercept, you're going to move until you get to the next point, the next, perfect crosshair in a square. And how do you get there? You have to either go up or down or left or right. You can't just cut across. The only way you can move on these graphs is to go up or down or left or right. You have to move on the lines that they give you. That's what these lines are all here for. That's how you have to move on the graph. So writing an equation from a graph is actually really easy because all you have to do is look at two things. That cross section where it crosses the y-axis, and how do you move to get to the next point. That's it. So I know that was a lot of notes for today. It was 3 whole pages of notes. But those are just some other ways that you can write your equation if you've been given different information. And so sometimes you'll see 2 points, sometimes you'll see a graph, sometimes you'll see a slope and 1 point. Sometimes they'll give you the slope and the y-intercept, and all you have to do is just write it in the right form. So there's lots of different ways that they may be giving you information, but you can put it all together to get the answer that you need. So for today, I only want you to write down these notes. I will upload pictures of all of them if you like to print them as well. And you can rewatch this video as many times as you need. You can pause it as many times as you need or go back and listen to all of it again. I know I moved fast, but I think you guys are capable of understanding it, and we will do some practice with all of these. So don't you worry, that is coming. Just make sure you get your notes for today. Thanks.